Okay, this video we're going to go over drop factor problems. You'll have some of these in your study guides, and this is a new type of math problem that we're introducing, and so most likely it will show up on your next exam for lecture. We're going to work through some problems. If you have any confusion or want extra problems to work through or have a question to go over, don't hesitate to reach out to us, and we will try to help you as best we can so you're confident with drop factor problems. Some things to think about when you're doing a drop factor problem is you need 3 pieces of information. Now when you get a problem on an exam, there may be more numbers in that problem, and don't let them confuse you. There's only 3 things you need to do a drop factor problem. You need the drop factor. The drop factor on a written problem should be given to you in the problem. It'll either be micro or macro. We'll talk more about that here in a moment. And if you're doing this in practice, it will be on the package of the tubing you're using to infuse that fluid. For instance, this one is 10 drops per milliliter if I was using this tubing to infuse. So that's your drop factor. You also need time in minutes, and you need volume in milliliters. And I like to make the note that you need to have the volume and the time need to be in correlation to each other. So it needs to be this volume in milliliters in this amount of time in minutes. And as we go through our problems, you'll see where you can do some variation there, but it's this volume and that amount of time. Now some other things to think about as you're going through your problems. The units, when you cross multiply, you remove your milliliters and you're going to end up with drops per minute, which is what we have set up here, drops per minute. That is your answer. In the lab, we're going to show you one more step where we're going to do drops per 15 seconds if you're the actual nurse going to the bedside. But on an exam, drops per minute is your final answer. We use basic rounding rules for these. We need to round to the whole number, because when you're counting drops, you can't count fractions of a drop. So basic rounding, if it's 5 or above, you're going to round up, and if it's 4 or below, you're going to round down. So very basic there. Now, other words you're going to hear come to your drop factors and the types of tubing you're going to use to infuse. You'll hear about micro tubing. So that's the type of tubing you're using to infuse your fluids. And you use micro tubing if your volume per hour is less than 100 milliliters per hour. So when you're infusing smaller amounts per hour, you use micro tubing. Micro tubing is always going to be 60 drops per milliliter. So it's a little bit easier to do some of the micro problems, and we'll show you in our examples when we go through those. The other type of tubing you'll hear about is macro tubing. So when you use macro tubing, your milliliters per hour to be infused will be at 100 milliliters per hour or more. So if you're infusing 100 milliliters per hour or more, you're going to use your macro tubing. Now the thing about macro tubing is that it can be variable. So it will have to say on your package what your drop factor is, or on an exam they will have to give it to you, because it will not always be the same for macro. So keep that in mind as you're doing these problems and you hear these words. So we're going to do the problems that you have in your module for your homework on your study guides. There were 4 problems. There were 2 macros and 2 micros. I'm going to work through those here, and you can work along with me. And again, if you have any questions, always reach out to us. We'll be more than happy to help you with these problems. So your problem 1 said you have D5W at KVO, which is 30 milliliters per hour. So if you see the sign KVO, that's keep vein open rate, which is 30 milliliters per hour standard. So if I have D5W at KVO, how am I going to do that? And this one said to use micro in the problem. So how I'm going to set that up is I'm going to do my drop factor, which is 60 drops per milliliter. And my time was 30 milliliters per hour. So an hour is 60 minutes. I'm going to multiply that by my volume, which was 30 milliliters per hour. So my volume was 30 milliliters. So drop factor was given to me in the problem saying to use micro. Micro is always 60 drops per milliliter. That was infused at 30 milliliters per hour, which is 60 minutes. So again, this volume in that amount of time. If I multiply this out, I can cancel my 60s. I can cancel out my milliliters, and I end up with 30 drops per minute. So for that first problem for D5W at KVO, which is 30 milliliters per hour, it comes out to be 30 drops per minute. I'm going to do the second problem. So the second problem said infuse 1,000 milliliters of lactated ringers over the next 8 hours. So, and this one was to use macro, which in your study guide, it told you that macro was 15 drops per milliliter. So I first need my drop factor, macro, and my text told me that was going to be 15 drops per milliliter. My volume, it said, was 1,000 milliliters over 8 hours. So I could use 8 hours, but I had to figure out how many minutes that was, which would be 480 minutes, and then I could use 1,000 milliliters. But to make it easy on myself, I took 1,000 divided by 8, because I'm given 1,000 milliliters over 8 hours, came out to be 125 milliliters per hour. So it just gives me smaller numbers. So I'm going to use an hour, which will be 60 minutes. And for 60 minutes, I'm infusing 125 milliliters. So if I work that problem out, I cross multiply, I get 1875 over 60 drops per minute. Multiply 1875 by 60 and I get 31.25 drops per minute. We said we can't calculate or count fractionals of drops, so the 2 says I keep this at 31 drops per minute is my answer. So to infuse 1,000 milliliters of lactated ringer over 8 hours, I reduced my infusion to be 125 milliliters per hour, multiplied it out, rounded, and got 31 drops per minute. Okay, the third problem said to infuse D5 half normal saline with 20 milliequivalents of KCl at 100 milliliters per hour. So here's an example where there's a lot of numbers in that problem, but we only need 3 pieces of information. For this problem, our text told us to do it at macro, and for these problems, macro is 15 drops per milliliter. So we want our drop factor, 15 drops per milliliter. So we are infusing 100 milliliters per hour. So I'm fine with those numbers. So hour is 60 minutes. And my volume is 100 milliliters. So I can cross multiply this one and I get 1,500 over 60. Divide 1,500 by 60 and I get 25 drops per minute. So to infuse D5 half normal saline with 20 milliequivalents of KCl at 100 milliliters per hour, I calculated that to be 25 drops per minute. Okay. So the fourth one said, infuse 500 milliliters of normal saline over the next 10 hours. And this one instructed me to use micro drip. So we know micro drip is always 60 drops per milliliter. My volume, so in this one, we have 500 milliliters over 10 hours. So I could use 600 minutes and 500 milliliters, because that's how many minutes are in 10 hours. Or I can take my 500, divide by 10 hours, and I get 50 drops per hour. So it just makes it easier on myself. So I'm going to use an hour for my time, which is 60 minutes, and my volume will be 50 milliliters.
Now, why don't you put 500 milliliters?
I could do 500 milliliters, but then my minutes would have to be 10 hours worth of minutes, which would be 600 minutes.
Okay, so
So
the
I
50
just-
goes with the 60 minutes.
Yeah, so this volume in this amount of time. And I just took my 500 milliliters, divided it by my 10 hours, so I get my milliliters per hour. So just so I have smaller numbers. You can do it either way. It's just more manageable for me if I use smaller numbers. So again, if you want to clarify that, just ask us. So again, this is micro drip over an hour. So the one thing you'll notice when you do micro drip problems over an hour, you can cancel out those two and your answer becomes 50 drops per minute. So this would be the answer I would put on a test or a homework, would be 50 drops per minute. We're going to do another sample problem that was not in your homework to show you when you're at the bedside. You're the nurse who's actually going to go into the bedside and infuse and set this up by gravity. You're going to take one additional step so it'll make it easier on yourself. So we're going to say we have an infusion of 100 milliliters per hour, which is going to be, I don't know, our secondary medication or our primary. It could be either one. So our drop factor, we're going to take off the package of the tubing we're going to use to infuse. So as you can see on this package, our drop factor is 10 drops per milliliter. So that's going to be my drop factor, 10 drops per milliliter. We said our infusion was 100 milliliters per hour. So my time is an hour, which is 60 minutes. And my volume was 100 milliliters. So I'm going to cross multiply, and I get 1,000 over 60. I divide 1,000 by 60, and I get 16.666. We need to round this. So this is larger than 5, so we round to 17 drops per minute. Now if this was on a test, that's my answer, right? But if I am going to the bedside, I'm going to be the one adjusting this, counting these drops. I'm going to make it easier on myself. I'm going to take my 17 drops per minute, take 17 divided by 4, because there are 4 15 seconds in 1 full minute. And I divide that out. I should get 4.25. Again, can't count 0.25. A 2 says that stays at a 4. And I get 4 drops per 15 seconds. So if you watch the videos for setting up infusions by gravity and you're at the bedside counting your drops in your drip chambers, it's easier for me as the nurse to readjust it every 15 seconds. So I can count 4 drops in 15 seconds and readjust if needed. I don't have to wait a full minute before I can readjust. So that's why we take one step further as the bedside nurse who's going to the bedside to infuse this infusion. We divide by 4 to calculate per 15 seconds. On an exam or on a homework, this is your answer, drops per minute, okay? And so that's how you do drop factor problems. And now that we've introduced it to you in the lab, you may see it on an exam going forward. So good luck with that.